Hi, welcome to today's astronomy video about orange dwarfs. These are the K-type stars. This is a nice overview of our interstellar neighborhood. Here's the Sun, solar system. The three most abundant star types are the red dwarfs, M stars, number 1 with 75%. Number 2 are the K stars, orange dwarfs, with a mass of 60 to 90% of Sun's mass, with 12%. And the Sun-like G stars are called yellow dwarfs. They make 8% of all stars. The closest K star to the Sun is in our neighbor system, an Alpha Centauri B. This is a nice picture of the two stars of the Alpha Centauri system, Alpha Centauri A, Alpha Centauri B. Alpha Centauri A is a bit more massive than the Sun, is a G-type star like the Sun. This K-type star B has a mass of 90% of the Sun. Here in the red circle you can see a faint reddish dot. That's the third star, Proxima Centauri, at a distance of 0.2 light years from these two other stars. With a mass of 12%, the Sun, so this is a red dwarf. This system has an age of 4.85 billion years. That's 250 million years more older than the solar system. The distance of the two big stars changes between 11 to 36 AU. 1 AU is Earth-Sun distance, 150 million kilometers. The orbital period of the two big stars is 79 years. And the orbital period of the third, Proxima Centauri, is 550,000 years. This is a nice picture of how the planet Proxima Centauri B could look like. It's probably a tidally locked eyeball planet with a mass of 1.2 Earth masses. Orbital period of this planet is 11 days. There was a candidate around Alpha Centauri B, the K star. That was the planet BB, but it was not confirmed. The other star, bigger star A, has also a Neptune-sized candidate, Alpha Centauri AB. And what's interesting about this big planet is that it's right in the habitable zone. This is an overview of circumbinary planets that can be found with the transit method. There are two types of these planets. There's the P-type planetary type, for example, on this system Kepler 16b. In this case, the planet orbits both of the stars. Or there can be a S-type satellite type, like Proxima Centauri B, that orbits only one of the stars. And many of these types of planets have probably migrated during their formation, and that's how they got to the position they're in. This is an ALMA image of the Epsilon Eridani. ALMA is the Ultra-Gamma Large Millimeter Array Telescope. It's another K-type star at 10.5 light years distance. It has 82% of the Sun's mass and 34% of the Sun's luminosity. The debris disk is inclined at 70 AU. By 34 degrees, that's why it looks a bit elliptical, but it's not really elliptical. This is a very young star with an age of 400 to 800 million years, and that's why its rotation period is short, 11 days, because it has not yet lost momentum to the stellar winds. This is a comparison of the Epsilon Eridani system compared to the solar system. You can see the Epsilon Eridani system looks like a mini version of the solar system. And both have an asteroid belt. Both have outside a big giant planet. Planet Epsilon Eridani B is at a distance of 3.5 AU. Jupiter is 5 AU. It has 76% of Jupiter's mass. The orbital period is 7.5 years. And you can see here there's an inner asteroid belt and the outer asteroid belt. Just like in the solar system, the habitable zone of this system is 0.5 to 1 AU. The planets in the habitable zone, if they exist, they should not be tidally locked because they are far enough away. That's the one big difference of orange dwarfs, A-type stars, compared to M dwarfs. These are red dwarfs. This is a nice artist's view of the glow from exozodiacal dust in the Epsilon Eridani system. This is how the sky of a hypothetical planet would look like. The dust grains have a size of 1 to 100 micrometers. This is another artist's image of the Epsilon Eridani system. The title of this image is Double the Rubble. That's because the system is a young system and there's still a lot of debris disk and dust in this system. This is another K-type star at 19 light years. That's Sigma Draconis. It has 85% of the sun's mass and 41% of the sun's luminosity. This star is visible to the naked eye in the night sky. And what's special about this star is its high elliptical orbital eccentricity of 0.30. The sun's eccentricity is just 6%. And what's special about K-stars compared to sun-like stars, the G-stars, is their long main sequence lifetime in the order of 40 billion years. For comparison, the sun's main sequence lifetime is just 10 billion years. This is another K-type star. There's a binary of K-type stars at 11.4 light years. That's 61 Cygni. The star A is 70% of the sun's mass. Star B is 63% of the sun's mass. This is animation from the motion from the years 2012 to 2020. The distance between the two stars changes between 44 and 124 AU. Orbital period is 659 years. And the age of the system is 5 to 7 billion years, which makes the system older than our solar system. There's another very interesting system. That's the Epsilon Indi system at 12 light years distance. At the left, you can see the main star. That's the Epsilon Indi A, K-type star with 75% the sun's mass. Its temperature is 4600 Kelvin, which is about 1000 Kelvin less than the sun's surface temperature. It is orbited by a pair of two brown dwarfs, Epsilon Indi BA and BB, and they are at a distance of about 2 AU and orbit each other at every 15 years. These are massive brown dwarfs with a mass of 60 and 40 Jupiter masses, and this system has also a Jupiter-type exoplanet. This is our artist's image of how the exoplanet Epsilon Indi AB could look like. It's a gas giant at 12 AU distance. It orbits the main star Epsilon Indi A, has 3.25 Jupiter masses, very massive planet. Orbital period is 30 years. And one difference to Jupiter is its high eccentricity of 0.48. The majority of gas giants, Jupiter-sized planets, have a higher eccentricity than Jupiter. Jupiter's eccentricity is just 5%, so that makes it special. And this system is a top candidate for the James Webb Space Telescope. This is another system, HD 219134 Gliese 892. It's a K-star at 21 light years distance. It has 81% of the sun's mass. You can see in this picture the planetary transit. And this system has also 6 planets, 3 super-Earths, 2 hot Neptunes, and further out a Saturn-type gas giant at 3 AU. But none of these 6 planets are in the habitable zone. This star is quite old with an age of 11 billion years. That's more than double the age of the solar system. This is where this star is located, HD 219134 Gliese 892. It's of the W shape of the constellation Cassiopeia. And you can see again the transit of the planet. It's another very interesting system. That's PDS-70. That's a VLT image, very large telescope image. For this image, a coronagraph was used that blocked the light from the central star. There's another K-type star at 370 light years distance with a mass of 76% of the sun. This is a young star called a Centauri type star. Its age is just 5 million years. And we can see in this image a planetary system in the making. That's the new planet that is about to form. And the size of the disk is 280 AU. This is animation from Hubble images of these types of stars. These are called Centauri stars. They're named after the young star Centauri. These are young variable stars that are not older than 10 million years. So at this young age, there's no hydrogen fusion yet. The energy comes from the contraction of the star. This animation that was made from Hubble images of a bubble of hot gas came from the binary system X Centauri. This bubble is larger than the solar system. The future of T Tauri stars is entering the main sequence after 100 million years. That's when the hydrogen fusion starts. This is a virtual trip to the system PDS-70. You will see the gas giant PDS-70b with 3 Jupiter masses, and there's another gas giant PDS-70c with 8 Jupiter masses. And you will see a moon-forming disk that is visible around the planet PDS-70c. This is PDS-70c. This is a nice AI image of another K star, that's Gliese 710. It's an orange dwarf at a distance of 62 light years. It has 57% of the sun's mass. It is a very young star with age of 300 million years. And what's special about this star is that it's on its way to the solar system. In 1.3 million years, it will come as close as 0.17 light years. There was an interesting number of astronomers estimated that there's a 1 in 3 million chance for Earth's transfer to this star. So this Gliese 710 could take the Earth away from the solar system. So this would what would that mean for life? Also, if Earth ended in the habitable zone of this Gliese 710 K star, that would be beneficial for life because this K star has a much longer main sequence lifetime than the Sun. So 1 is in 3 million, so this means that's probably not going to happen. But the Milky Way contains 100 to 400 billion stars, each have their individual orbits. So that makes it very likely that this kind of incident could happen. For example, ejections or transfers of planets would be very well possible if one star in the Milky Way is approached by another star. And that was today's video about A-type stars, the orange dwarfs. You can check out the links in the description field to the scientific articles. Thank you for watching. Have a nice day. Bye-bye.